In the second part of this video, we're going to examine patterns in early childhood math and later in elementary school, and we're going to begin to talk about numeracy, probably one of the most important aspects of early childhood math. As we talk about patterns, we're going to look at two different kinds. Repeating patterns, the kind that's dealt with the most in early childhood math, and then growing patterns. Later in elementary school, they start to look at growing patterns. We'll look at objectives, materials, and activities that can be used for both repeating patterns and growing patterns. Repeating patterns are something like this. Smile, stick out your tongue, wink. Smile, stick out your tongue, wink. Smile, stick out your tongue, wink. What you have is a core that gets duplicated again and again and again. If you're giving a child a repeating pattern to identify, you want to make sure that you give them at least 3 instances of the core to work from. If you only put 2, it could be a growing pattern and they have no way to know. Now, as you deal with repeating patterns, there's a series of 7 objectives or activities that typically children do. These are sequenced from easiest to hardest. The first one involves just copying a pattern. The next involves looking at the pattern, identifying, and explaining it. In this instance, there's 1 heart and 2 stars that make up the core, and that core is repeated again and again. A next skill is to extend a pattern, to say what comes next. And in this instance, it would be a heart. Or the missing element can be somewhere in the process of the pattern. In this instance, what's missing from the box area is a heart. Children also create patterns, and they can do it all different ways. They can clap patterns, they can move patterns, they can sing patterns, they can draw patterns, but creating patterns is part of the pattern learning process. And then they learn to represent patterns. So if I were to look at this pattern, I would see it's an ABB pattern. The heart is first, that's the A, and then the star is second, that's the B. There's 1 heart, 2 stars, 1 A, 2 B's. And they're representing patterns today in Texas as early as 1st grade. They also translate representations into patterns. So you might say, make an ABB pattern. Could be they do it with stuff. Here's a card and 2 buttons, a card and 2 buttons. Again, they could use innumerable things and a lot of creativity in creating these. In later math, they deal with growing patterns. Here's an example. It's a series of steps, and each new step is really related to the previous step according to the system or pattern. If you look, the first element has 1 orange arrow, the second has 2, the third has 3, the fourth has 4. There's a pattern. 1, 2, 3, 4. As children deal with growing patterns, they look at each little part. It's not a core, it's a term. So there's a term 1, 2, 3, 4. And they count the number of items in the term. The number of items is the elements. So term 1 has 2, term 2 has 3, term 3 has 4, term 4 has 5. And they learn this language. They also start as they get a little older, but we're still talking elementary school, to look at the relationship between the term and the number of elements. The term and the number of elements. They can look at this and see, wow, the number of elements is always one more than the term. As they do growing pattern activities, they identify and explain. They describe the pattern. They use vocabulary, term, number of elements. They identify the change from term to term. They extend and add the next term or step. They create their own. And then they represent, not with letters, but with a table, a graph, or an algebraic expression. And ultimately, they can predict the number of elements in a given term. For instance, here's a growing pattern. The first term has 5 elements, the second term 9, the third term 13, the fourth term 17. Ultimately, the 7th term would have 29. The number of elements is 4 times the term plus 1. And I could represent it in a table like this or on a graph. Now, with patterns just like classification, there's lots and lots of activities that can be used. A lot of the patterning activities, the classifying activities can be used to pattern, but you have to have a whole lot of each kind. What I'd like you to do is 2 things. First, add to your journal a list. Brainstorm at least 5 materials that could be used for patterning. Some of them can be some of the same ones used for classifying. And then brainstorm a second list of 5 activities that could be used, including art projects. Children might make bracelets or necklaces by stringing cereal or pasta or those kinds of things, and do the stringing and the creating in patterns. Now, the next part we're going to start is numeracy. We'll start it, you'll watch another video, and then in the live class, face-to-face class, you'll continue and finish this. Numeracy is what's sometimes called number sense. Being able to really understand numbers, compose and decompose them, and use them flexibly. It involves comparing, counting, subitizing, representing, using number relationships, and estimating. What we're going to look at is comparing and a little bit to begin counting. As little children compare, they learn relational words, as many as, or the same as, more than, less than, or fewer than. If there's a small number and the number is different, they can look without counting and tell there are fewer red or that there are more blue. Children tend to have more trouble with less than or fewer than, I think in part because we tend to not ask them. It's easy to say which has more, how much more, rather than which has fewer, how many fewer. You need to discipline yourself to ask both kinds of questions. Now, I'd like you to watch what's happening, what's being demonstrated as a child compares the blue hearts to the red hearts. What happened? You're right. They determined that there are more red hearts by lining them up or doing what we call one-to-one correspondence. They've matched. When it was just a clump of red, a clump of blue, it was hard to see how many more or how many fewer. But lined up like this, you can see. One-to-one correspondence is an important math skill. And I'd like you to think a little bit about how could you help children develop this skill or understanding. As you read your chapter about early childhood, you'll be given some additional ideas. Now, we're going to start but not finish talking about counting. Counting is probably a very misunderstood kind of skill. A child can say the number words to 100, and his mom and dad very proudly say, my child can count to 100. But you give them a group of 8 beans and they can't figure out how many there are. That's because there's kinds of counting. There's rote counting. That's the child that can say the number words to 100. And rational counting. That's the child that can actually determine accurately the correct number in a set. So rote counting is saying the number words in order. 1, 2, 3, 4, 5, 6. Children learn that a lot through songs and rhymes and games and books. And it's important. It's the beginning of counting. But they also need rational counting, where they accurately determine the number of objects in a set. If a child were to determine or count the number of triangles here, he might say 1, 2, 3, 4, 5, 6, 7, 8, 9, there's 9. The child could rote count to 9, but couldn't rational count because there were some of the ideas, some of the key principles involved in counting that most of us that have been counting for a very long time take for granted. Counting principles, a stable order for the number words. You don't get to choose what comes next. I remember my daughter as a child would say the alphabet and she would say A, B, C, D, R. And I would say, no, Laurie, it's A, B, C, D, E. And she'd say, Mom, if you want E to come next in your alphabet, that's okay. But I don't want it next in mine. The truth is, she didn't have a choice. There is a stable, predetermined order in the alphabet and in the number words. There's also what we talked about, one-to-one correspondence, one number word for each item, and the idea of cardinality. The last number named is the total. In Texas right now, the preschool standards are children should be able to rote count to 30, rational count to 10. The kindergarten, they should be able to rote count to 100, rational to 20. Doesn't mean they shouldn't be able to do more, but those are kind of minimum standards that we need to establish in our children. Now, what I'm going to want you to do in a minute is close this presentation and open a video in Blackboard. This one is a video of little Josh, a bright kindergarten child, counting. I want you to watch carefully and see what Josh can do and what he can't do. It's easy to be overwhelmed with this child is making major mistakes, but embedded in his major mistakes are a lot of knowledge and skill that's important that he has. So look and see and note what he can do, what he can't do. And then think about what would you do to help him progress. One of the last things you're going to do in your journal for this first part of early childhood is answer the questions. What can he do? What can he not do? What would you do to help him? So again, after watching the video clip, record your answers on the questions in the record-keeping packet. This concludes the second half of the first PowerPoint. When you come to class, to the face-to-face class, please bring your journal with all the different answers that have been enumerated during this video. And make sure you have your list of your 5 favorite activities included.